picture tadi tu. Okay. Where is it? Okay, right here. So ni maksudnya yang range tu is included with the uncertainty range sekali. Tapi dia akan describe pass or fail. So within the range dia adalah pass. Maksudnya the pass result is from here C measure minus U and C measure plus U. That's why measure plus and minus. So this yang blue color ni adalah you punya range of testing yang show pass. Okay, range of testing yang show you punya result is pass. So macam tu. Any question for this? Okay, so if no question, all right. So if no question, okay, if no question, I bagi you take 5 sekejap sebelum kita buat the fishbone. Okay, so I bagi you take 5. Now 10:25, 10:30 we continue. Hey, everyone is already back. Everyone ready? Okay, we wait another 2 minutes. Okay, so ready. Alright. Okay, so let's continue. So so we stop here before we go for short break. Okay. Okay, so uncertainty range. So this is explain what is uncertainty range. Okay. Okay. And then source of measurement uncertainty example by sample handling. Okay. Sample preparation, instrument or apparatus. Okay, sample handling basically affect the homogeneity or storage condition. Okay. Sample preparation by weighing or the preparation process lah. If we need to do any digestion. Okay. Right. Maybe sample is not so related with you. Okay, it's related to you. Instrument or apparatus, maybe. Okay. So by the calibration, not your calibration process, but your maybe your standard weight, okay, or your calibrator and temperature effect, reagent, okay, source of uncertainty, environmental condition. I think you need to consider this. Okay, sample effect, recovery, interference, and stability. Okay. So blank correction, okay, if tak ada tak apa ini, okay, human, okay, is operator bias, random effect, okay, by operators, instrument, human, and stability, ini random effect lah. Okay, randomly, we don't know what is the real factor. Okay. All right. So identify uncertainty component. Okay, uncertainty component, we start with basic expression. We include other effect. Kita guna fishbone. Okay. So basically to identify the uncertainty, we use the fishbone. Okay. Okay, so okay, for example, ni example number 1, uncertainty in weighing. Okay, uncertainty in weighing process. Okay, weighing process. Okay, so balance calibration, readability, and run-to-run variation. So the total uncertainty of weighing process is we combine the uncertainty in calibration, which is you can get from the calibration certificate, plus the repeatability, yang ini yang you all buat dekat you punya lab, okay, replicate number of measurement, and the readability, okay. Readability also sometimes kita boleh dapat dekat dalam our calibration certificate, okay. So balance calibration state on calibration certificate converted to standard deviation, okay. And then readability, limited resolution. Readability ni also if I'm not mistaken, you boleh dapat dekat the instrument kot, if I'm not mistaken. Okay. And run-to-run variation, yang ini yang standard deviation, successive sample of check weight. Okay. Alright, so this is the formula. Okay. Ada consideration density effect lah. Okay. Ni kalau ada. Okay. Okay, example. Calibration uncertainty. Okay, uncertainty in volumetric glassware, this one. So kita come out with the table macam ni, we combine the uncertainty. Okay, first uncertainty in calibration of the glassware, the temperature, kita pun tahu, okay, kalau glassware biasanya you akan nampak 23 degree Celsius atau 25 degree Celsius. Okay, itu dia punya temperature masa dia buat calibration lah. When comes dekat Malaysia ni, kita punya room temperature pun dah 30. Okay, so dia ada delta T kat situ. Okay. And run-to-run variation. Okay. So example calibration uncertainty yang first. Okay. Method you nak dapat mana? When do you want to look for the sample? Okay, state in manufacturer specification. Okay, dia ada dekat manufacturer specification, then you convert to standard deviation. Okay, so example 10 ml grade A. Okay, 10 ml maybe volumetric flask. Okay, so dia punya uncertainty is 0.01 mil. Okay, it is given actually. Okay. Okay, ni calibration uncertainty. So the method of determination for temperature. Okay. Okay. So temperature variation from the calibration temperature cause the difference in the volume. Yes. Okay, because volume expand together with temperature. Okay. So this is the formula. Delta T times alpha over 2 over 3 square root of 3. Okay, and then the coefficient is 2 times 10 negative 4 per Kelvin for water. Okay. Okay, so run-to-run variation, replicate this one run-to-run variation, standard deviation of successive check delivery found by weight. Okay, replicate fill, you fill 25 mil over weight, so you dapat standard deviation. Okay, this one basically we carry out in our lab. So uncertainty in volumetric glassware. Okay, so come to the fishbone. This is how we identify the sources of uncertainty. For example, uncertainty due to sample and sampling. Okay, so we draw the fishbone. So we draw the straight line. We draw the straight line here is your sample. Okay, or measure n. Then we consider the factor of uncertainty. Okay, first for sampling, maybe sample inhomogeneity during the sampling. Okay, and then maybe the laboratory environment for the testing, for the sampling. The storage condition, or maybe the sample is deteriorate. Okay, so this uncertainty due to sample and sampling. Okay, the fishbone. Number 2 is a chemical effect. Okay, based on your practice, I mean based on your method sebenarnya. Yang ni kena based on your method. Okay, so either incomplete extraction happen, maybe then you gonna consider as uncertainty lah. Incomplete dissolution, then you gonna consider uncertainty lah. Okay, absorption, measurement condition. Okay, incomplete digestion. Ini for example chemical effect. Okay, kita ambil example yang ini. Alright. Preparation of calibration standard solution. Okay, calibration standard solution. Dia punya process flow. Okay. Procedure. Weight standard material of certain purity. Okay, kita ada purity, kita ada weight factor dia. Factor pertama kita ada weight, purity, and volume. Okay, these three factor we use to prepare the calibration standard solution. So the concentration formula is equal 1000 mp over V. Okay, milligram per liter. Then we come with the uncertainty component. Okay, kita buat uncertainty component from weight, purity, and volume yang kita ada. Weight, purity, and volume is source of uncertainty. Okay. Okay, so weight is source of uncertainty. This one is source of uncertainty. EP and this one is B. Okay. First, we draw the straight line here. Okay, we draw the straight line here. Okay, sebab kita ada source of uncertainty, weight, purity, and volume. Okay, so we draw the straight line. We draw the straight line. Macam mana mau tulis ni? Boleh lah. I try. Alright, so insert. So I try lah. Okay, we draw the straight line. So we look for the concentration. Actually, our measure N is the concentration. Okay, so C lah concentration. Okay, so tadi our source of uncertainty. Ya, tulis ni. Okay, so we have weight, we have volume, and we have purity. Because this is only factor yang ada dalam eksperimen tu. Okay, kita ada weight, volume, and purity. Because these three akan contribute to uncertainty. Okay, and then yeah. So first kita ada purity. Here kita ada P. Kita buat fishbone ya sekarang. This is our fishbone. So we determine and then we have volume here. Okay. Kita ada weight satu lagi kita tinggal. Ini tulang besar. Salah. So to determine the source of uncertainty, okay, it is important you buat fishbone dulu. W. Alright, W. Okay, ini tulang besar. Tulang ikan yang besar lah. Alright. Okay. So purity. Okay, purity is your chemical punya purity lah. Yang ini memang tak ada apa-apa lagi faktor yang kita boleh contribute dekat tengah. Tulang kecil dia tak ada. Okay, untuk weight. Okay, weight. Kita kena tahu. You kena consider tare weight dengan gross weight. Tare weight tu yang you tekan zero dulu. Okay, and you kena consider the human error. Ni example untuk weighing balance You kena consider the human error happen. Mungkin ada orang yang akan pergi dan dia tak akan terlupa nak tekan tare weight. So you kena consider two item here. So you consider item here. Okay. So you consider dua benda lah, gross dengan tare. Gross weight and tare weight. So you consider dua benda ni lah. Okay. So fishbone you belum habis lagi You baru ada yang big one, tulang besar, purity, volume and weight. So baru pecah weight. Weight ada dua factor lagi. From weight kita ada gross weight dengan tare weight. Source of uncertainty kita. Okay. And then source of uncertainty here. Okay, dekat gross weight dengan tare weight kita ada lagi kita punya uncertainty. Okay. Kalau you tengok slide tadi, kita ada calibration uncertainty. calibration, and pun kita consider benda yang sama dekat sebelah lah. So you ada calibration and calibration uncertainty. Okay, kalau you tengok slide, I rasa you ada slide tadi. Yang tadi tu you nampak for uncertainty in weighing ada 3 kan? Calibration, reproducibility and repeatability. Sorry, repeatability is reproduce. Readability, dia ada 3 factor. Okay, tak apalah kalau you pening-pening tercekik tu ikan ni pun nak buat macam mana lah. Okay, because it is not easy for me to explain virtual sebenarnya, but I try lah. Okay, so we have another factor is repeatability. Okay, and here is readability of the instrument lah. Okay, so benda yang sama juga dekat terawatt, same item dekat terawatt. Okay.